Hello, this is Mr. Wynn, and today's lesson is about solving polynomial equations. So, first, make sure you know factor polynomials. In 4.3, you learned quadratics can be factored. Now, when we have polynomials of higher degree, there are other ways to factor them. So, there are special rules. The first one is the sum of two cubes. If you have something cubed plus something else cubed, it turns into this. Right? Now, that's just cube rooting the first thing and cube rooting the second thing. So cube root this, cube root that. So cube root of a cubed is a, because a times a times a is a cubed. Cube root of b cubed is b. And you do that first number, the second thing, square that first number, multiply the two, and then square the second thing. And then the signs between them I'll talk about in a second. For difference of two cubes, again, if you have something cubed minus something else cubed, it turns into that. And then if they can't be factored, they call them prime. Now this is on the formula chart, but we call it the SOAP formula. So if I give you something, again, say a cubed plus b cubed, I need to take the cube root of both of them. So cube root of a cubed is a, cube root of b cubed is b. Then I'm going to do the first thing squared, a squared, multiply them, ab, and the second thing squared, b squared. See, there are three spaces. There's something right here, and right here. Those are the signs, either plus or minus sign. SOAP comes from the word same sign. O stands for opposite sign. And A is always positive, always plus. AP is always plus. And same as the original. So that first sign, since this was a positive, it's the same. That's going to be a plus sign. Next is going to be opposite. So the first one is positive. I'll do this. So this is positive. Goes in this box. This next one is opposite. So that means it's negative. And the last one's always positive. So if you see, that should match the same formula above right here. That's why it's plus, minus, plus. If it's the other case scenario, if it's minus, I mean same is minus, opposite is plus, always positive, plus. So that's the way to memorize or remember both formulas. Alright, so here's the first example. Factor completely. Well, I see they're both cubic terms. See, x cubed, y cubed. That means I'm going to try to cube root both of them. So if I cube root this and cube root this, I get, well, the cube root of 8 is 2, because 2 times 2 is 4 times 2 is 8, and x. Right? 27y cubed is really 3y, because 3y times 3y times 3y is 27y cubed. Alright, the first thing squared, 2x times 2x is 4x squared. Multiply them, 2x times 3y is 6xy. And then multiply the last one, like square it, 3y times 3y is 9y squared. I'm using SOAP here. The original problem said to add. So, same, opposite, always positive. And that is my answer. Alright, now in the second example, I see a fourth power and third power. Remember, you're technically supposed to always do GCF first. So I can take out a y and a 5 out of both of these. Alright, when I do that, what's left over is y cubed. And 320 divided by 5 is 64. Z cubed. Alright, so I'm going to leave the 5y alone in front, but y cubed plus 64z cubed, that's a sum of perfect cubes. So I'm going to cube root both of them. Alright, cube root of y cubed is y. Cube root of 64z cubed is 4z, because 4z times 4z times 4z is 64z cubed. Square the first thing, multiply them, so 4yz. Square the last thing, 16z squared. Alright, and then the signs for SOAP, same, opposite, always positive. There's my answer. Alright, here's all the methods possible. So remember, if there's any number, make sure you do GCF. When there's 2, check if it's difference of 2 squares, sum of 2 cubes, or difference of 2 cubes. Those bottom to the sub formula. If there's 3 of them, we do the trinomials. That's the X method, if you remember that. And there's 4 more, we do grouping. We always want 2 groups and try to make the inside parentheses the same. So factor by grouping. There's 6 terms. I want 2 groups. That means I'm going to do groups of 3. I'm going to do this group as one and this group as another. For the first one, I see I can take out x squared. What's left would be x squared plus 7x minus 4. For the second group, I see I can take out, what's that? They're all even, 2. Alright, 2, anything else? Nope. What's left would be 5x squared minus 14x minus 8. No, plus 8 minus 8 minus 20. Alright, now those insides didn't match, so now I have to redo this. I'm going to try a different group. Sometimes they make you reorder it, so I'm going to fix or switch these 2 terms. So I'm going to say, let me do this. X to the 4th plus 7x3 plus 10x squared minus 4x squared minus 28x minus 40. Alright, I'll try the 2 groups again. Let's try this group of 3 and the other group of 3. Well, again, this is still x squared, so what's left is x squared plus 7x plus 10. This other one, I can take out a negative 4. What's left was x squared plus 7x plus 10. Now the insides match. So that is my GCF. I take that out. I'll put in here x squared plus 7x plus 10. What's left over would be x squared minus 4. Now sometimes we'd be done here, but you have to factor both of those again. So the first one, if you do the x method, that's really x plus 5 times x plus 2. The second one, that's a difference of perfect squares. That means I'm going to square root both of them. X squared, square root of that is just x and x. Square root of 4 is 2 and 2. You can change signs, so positive, negative. That is my answer. If you FOIL and distribute all those terms, you get the original problem back. Alright, factor completely. Here, this is combining perfect cubes and squares. Notice, this is really x squared cubed, or you could say x cubed squared. So it's something squared or something cubed. So technically we use both of those formulas, the SOAP formula and the difference formula. So to make life easier, you should do the difference of squares first. So I'm going to take the square root of both of them. Square root of x cubed is x3. Square root of y cubed is y6 is y3. Positive, negative. Now this left side is the sum of perfect squares. The right side is the difference of perfect squares. So for both of them, I got to factor some more. Alright, so the cube root of x cubed is x. Cube root of y cubed is y. Square the first thing, multiply them, square the second thing. SOAP, so same, opposite, always positive. That's for the left one. That's x cubed, y cubed. Adding. Now the other one. Cubed root of x cubed is still x. Cubed root of y cubed is still y. Square the first thing, multiply them, square the second thing. SOAP formula, since this was a minus sign this time, it was a minus sign, it's same, opposite, always positive. And that is our answer. Alright. In some cases, you can rewrite a polynomial into the form of a times u squared plus bu plus c by letting u equals x squared. That's called u substitution. You replace something with something else temporarily. So look at their example. You have x to the 4th power plus 12x squared plus 32. That can be seen as x squared squared plus 12x squared plus 32. Because x squared squared is x to the 4th. But now it's something quadratic. Because I could put the letter u here. So that'd be u squared plus 12u plus 32. Now we could do quadratic formula. Alright, so there's the key concept. Basically, you're trying to figure out if you can, if the middle term can become the first term if it's double power, I guess, if you can double the power. So here I'm going to say let's let u be x squared, because this is again x squared plus just x squared minus 90 equals 0. Well, I'll call that u. So u squared plus u minus 90 equals 0. Now you can do quadratic formula. I'm going to do the shortcut and just factor. So that turns into u, let's see, plus 10 times u minus 9 equals 0. I'm going to use the zero product property. So set each equal to 0. U plus 10 equals 0. U minus 9 equals 0. Well, if you solve for u equals negative 10, and u equals positive 9. Now to put u back to normal, so that means u was really x squared, this is really x squared equals negative 10, and x squared equals 9. I gotta solve for x, so I square root this and square root this. X equals plus or minus I root 10. There's two answers there. And over here, square both of this. X equals plus or minus 3. So they're my four answers, my four roots. Remember, the degree is 4. There's 4 answers. 2 imaginary, 2 real. All right, here's your practice problem. Try it. That should be your answer. If you knew that, you should be fine for class. Again, this is Ms. Wynn. Thanks for watching. See you later.